Hey guys, I have here a 12V 200Ah lithium iron phosphate battery from Timeusb. We're going to run through the usual review process here today. We'll take a look at the battery features, we'll run a capacity test, and then we'll tear it down and see how it's built inside. Additionally, they did send out their DC power distributor box here, which allows for charging and powering multiple DC devices at the same time, so we'll be taking a look at this as well. It's been about 2 months since my last video, so this is a great way to get back into it. By the way, if you haven't seen my new channel yet, please head on over, check it out, and hit that subscribe button. The new channel focuses on servers, networking, and general IT. I've been spending quite a lot of time there recently, and there's a lot of great content on the way. This battery measures 21 inches in length, 8.5 inches in height, and 8¼ inches in depth. It's a standard plastic ABS case like we've seen in most of these batteries. Taking a look at the left-hand side, we have our main positive and negative. They're the standard epoxied-in terminals. And this battery came with 4 M8 bolts. You see each one has a split lock washer and a flat washer. All 4 bolts are the same size. Additionally, we have a pair of terminal covers as well. We have the serial number of the battery and a nylon carry handle strap on each side. I did notice there is a bit of plastic discoloration around this terminal. I'm not sure what's up with that. We'll see what's on the other side of this lid when we take it apart. Product manual is fairly straightforward. It's a 200 amp hour battery, as we already noted. Has a recommended charge of 40 amps or 0.2 C. This is the Plus model battery here. You see it says Plus on the case, which means it has a 200 amp BMS. So we can charge and discharge this battery at 200 amps continuous, and it's got a max surge rating of 400 amps. We can see the charge and discharge temperatures here. This battery does not advertise having low temperature charge protection, so you'll want to make sure it's above freezing when you charge your battery. You can wire up to 4 of these batteries in series for a 48 volt system. As always, if you plan to do 48 volts, I recommend purchasing a 48 volt battery. And the last few pages of this booklet show different ways you can connect in various series and parallel configurations. And this is the DC power distribution box they sent out. This is a very neat device. So we have an on-off switch here. We have 2 DC barrel outputs. We have your standard automobile accessory plug here, traditionally referred to as a cigarette lighter jack, but this is definitely not a cigarette lighter. We have 2 USB 2.4 amp ports, 2 quick charge 3.0 ports, and 2 USB-C power delivery ports. On the bottom, this device has an Anderson SB50 input, an Anderson SB50 output, and you see it can support up to 40 amps. So you can wire one side of this to your battery, and then one side of this off to a separate small load. This product includes a 15-foot cable to connect the distribution box to your battery. This cable is built with 11 gauge conductors. You see we have an Anderson SB50 connector on one end, and the other end of the cable has some nice crimped on ring terminals to go directly to your battery. So there is no custom cabling work needed to connect this box. However, if you're interested in building your own cable or maybe a longer cable, they did include an Anderson connector with 2 pins here, so you can just crimp this on and you're good to go. And this product also came with its own user's manual. And I do see here that it's noting this is a 40 amp Anderson connector, so it's likely not an SB50. Alright, so we've got our cable connected to our battery up there. Okay, power on. Wow, that's pretty cool, look at that. So our battery's sitting at 12.8 volts currently, and we have our little SOC gauge over here, which it must be determining this based on voltage. If you're using this battery in an RV, a camper, or some other portable application, I can see this device being very, very handy. You have pretty much everything you need on here for your standard mobile devices, whether it be your phones, your iPads, any sort of laptop would plug in the accessory port. You don't have to worry about hauling around an inverter, and you don't have the additional efficiency loss caused by the inverter. Like usual, I charge this battery using my Ames Power 12 volts, approximately 75 amp charger. And this is the same typical capacity testing setup. We have a Batrium shunt. Batrium's off camera back there. It's transmitting data to this display. We have the voltage, amperage, wattage, and then we have the discharged amp hours and the discharged watt hours. And my test load will be this space heater here. And we're at approximately 918 watts. That's 70 amps at the current voltage. We'll leave this run until the BMS in our battery shuts down our test, and then we'll see what our measured capacity is. And our test concluded just a few minutes ago, and we came in at 200.79 amp hours. Perfect. All right, battery. Taking a look at the inside of our battery, right away we see the rather large BMS going across the top here. And this does look similar to some of the BMSs we've seen in other batteries. Our cabling here, on the negative side, we have 2 separate runs of 3 conductors each. So there are a total of 6 conductors here. 3 conductors go to each crimped on lug. The conductors are number 10 gauge wire, silicone insulated, so a 200 degrees Celsius insulation rating. The output wiring is the same way from the BMS here. We have a total of 6 number 10s going from the BMS to 2 lugs which tie into the battery. On the positive side here, we have a pair of 6 gauge conductors, silicone insulated wire as well. And this is some nice thick beefy wiring here, so I'm very happy to see that. Taking a look at the BMS here, we see a lead comes off and goes down to the battery. This is going to be a thermal switch for over temperature protection. I'm going to go ahead and slide out this battery and we'll take a closer look. Guys, look at this foam thing going across the top here. They have it punched out every place there's a vent, and they also have it punched out every place there's a retaining clip between the cells. Look at that. I've never seen such a well-designed piece of foam before. That's very, very cool. It's just fun to look at. So I did notice one minor problem as I was disassembling this. They used nylon straps, which isn't a problem in itself. However, the end plates they use here at the end of the cells, it's broken one of them on one side. And you can see this corner on the other side is close to breaking as well. And that's not damage I had done. It was like that when I opened it. And actually look, this side's about to break here as well. This plastic's coming off. But regardless of whether or not it was over tightened, this plastic at the end is just very brittle. So if I did have to make one recommendation, it would be a better end plate for the battery pack itself. Other than that, this battery pack appears to be designed very, very well. There is a plastic plate between every single one of these cells, isolating it from adjoining cells. The cells are all perfectly square. I don't see any bulging or deformations, dents, anything like that anywhere on the sides or the bottoms of the cells. These cells are laser welded together with some aluminum strips. They are fairly thick aluminum strips. They're laser welded very well. They do have these expansion lumps in the center, which I like seeing, to prevent tension from being exerted on these posts if the battery were to expand and contract. For the main positive and negative connection, you can see they are laser welded aluminum strips as well, and then they're bent up at an angle pattern here with a nut plate on the back of each side. So we have 8 100 amp hour cells here. They are connected in pairs of 2 in parallel, and then those parallel groupings are wired in series. That gives us a 12 volt battery. And I don't know if you can see that QR code there. These are GFB cells, model 0ALCBA3510000D. GFB cells have come to earn themselves a fantastic reputation in recent years. The balance leads are built with high quality 24 gauge wire. This has a nice hard insulation to it. The balance leads are run very nicely through these plastic clips on each one of the separators between the cells the whole way up the battery pack. The ends are terminated with ring terminals. They are screwed directly into the bus bars, and you can see each one's labeled with the appropriate position. This is B2. This one says B+. Taking a look at our BMS here, you can see the part number there in the lower left-hand corner if you're interested. It is dated July 15th, 2022, and this BMS is labeled with their own brand name. I was not successful in removing this foam to see the rest of the label, and I didn't want to totally destroy it, but I was able to get enough off that I see their brand name, the model number that matches that of the PCB, and I see it also says 4S down here in the left-hand corner. The lead connections are soldered into place. They look like they're done pretty well. We've seen some pretty bad ones over the years, and I don't see any problems whatsoever with how these wires are soldered on here. I'm not going to take this apart any further. I think we've seen enough BMSs already. Before we go, last test is going to be to make sure this high temperature thermal switch works and shuts down the BMS. There are no temperature sensors on this BMS. It's not advertised as having temperature protection, so I'm not going to test for that. And this switch is listed at 75 degrees Celsius. You can see on the clamp meter we're charging 82 amps here. And there we go, it's stopped charging. We've dropped to 0 amps. So I'm going to go ahead and cool off this sensor and just make sure it starts again. And there we go, it's resumed charging, 81 amps. Works perfectly. So there we go, this battery tested out pretty well. We hit our 200 amp hour mark, the high temperature protection worked, and we have quality GFB cells. Maybe a little bit of improvement would be nice on the end plates that secure the pack together, but otherwise the pack works and functions exactly as designed. This battery sells for $630 on their website and on Amazon. They have a wide range of batteries from 50 amp hours all the way up to 410 amp hours in the 12 volt configuration, and they also have some 24 volt models available as well. This DC distributor box sells for $120 on both Amazon and their website. And this DC box will work with any battery. It doesn't have to be their brand batteries. So if you already have some batteries you're using and you just like this DC distributor box, you can go ahead and purchase one of these and connect it to your existing 12 volt battery bank. Any questions or comments, feel free to leave those. Hit that like button before you go, and thanks for watching.